Let's start amines. The chief commercial use of amine is as intermediate in the synthesis of medicines and fibers. Amines constitute an important class of organic compounds derived by replacing one or more hydrogen atoms of ammonia molecules by alkyl or aryl groups. In nature, they occur among proteins, vitamins, alkaloids, and hormones. Synthetic example includes polymer, dyestuffs, and drugs. Two biologically active compounds, namely adrenaline and ephedrine, both containing secondary amino groups, are used to increase blood pressure. Novocaine, a synthetic amino compound, is used as an anesthetic in dentistry. Benadryl, a well-known antihistaminic drug, contains tertiary amino groups. Quaternary ammonium salts are used as surfactants. Diazonium salts are intermediate in the preparation of variety of aromatic compounds, including dyes. In this unit, you will learn about amines and diazonium salts. So let's learn about amines. Amines can be considered as derivatives of ammonia, obtained by replacement of one, two, or all three hydrogen atoms by alkyl or aryl groups. For example, here, ammonia is NH3. So when we replace 1, 2 or all 3 hydrogens with alkyl group or with aryl groups, you will get amines. Here in the first example, CH3 single bond NH2 means one of the hydrogen of ammonia is replaced with methyl group. In the second example, one of the hydrogen of ammonia is replaced with phenyl group. This is C6H5. In the third example, here there is NH, means there are two hydrogens are replaced with methyl groups. In the next example, there all the three hydrogens are replaced with methyl groups. Now come to the structure of amines. Like ammonia, nitrogen atom of amine is trivalent and carries an unshared pair of electrons. First of all, draw the structure of ammonia. In ammonia, there is nitrogen which is bonded to three hydrogens. So there are three hydrogens bonded to nitrogen. And nitrogen has a lone pair. So this is lone pair. As it has one lone pair and three bond pairs, the hybridization of nitrogen in ammonia is sp3. As the hybridization is sp3, bond angle for sp3 is 109 degree 45 minutes. But due to presence of lone pair, means according to VSE PR theory, valence shell electron pair repulsion theory. So according to VSE PR theory, there is maximum repulsion between lone pair and lone pair. Then lone pair, bond pair, bond pair, bond pair. For sp3, the shape of molecule should be tetrahedral. So let's draw the structure of ammonia. So this is nitrogen and there is lone pair. If we draw the structure of ammonia as tetrahedral, so this is tetrahedral structure for ammonia, but because of lone pair bond pair repulsion, lone pair bond pair repulsion, this lone pair pushes this bond pair and this side also it pushes the bond pair. As it pushes the bond pair, the bond angle decreases to 107 degree, 28 minutes. So this bond angle decreases to 107 degree from 109 degree due to lone pair bond pair repulsion. Now in amine, amines are the substituted ammonia, means when you replace 1, 2 or all 3 hydrogens with the alkyl or aryl group, you will get amine. So if I replace all the hydrogens with alkyl group, so here this is nitrogen and here I have replaced all the hydrogens with CH3 group. These CH3 groups are quite bigger as compared to single hydrogen. So these groups are bigger as compared to single hydrogen, and in amine also there is lone pair of electron over nitrogen. And this lone pair pushes the bond pairs. But because of the bulky nature of methyl group, the bond angle increases a little bit. So here in case of this amine, tertiary amine, bond angle is 108 degree, which is more than 107 degree of ammonia and less than 109 degree, which is expected bond angle for sp3 hybridization. Now let's read from the book. Nitrogen orbitals in amine, they are full sp3 hybridized, and the geometry of amine is pyramidal. In case of ammonia, these lone pairs are not visible in the geometry, as the lone pairs are not visible in the geometry. That's why the shape of ammonia is pyramidal. Similarly, in case of amine also, these lone pairs are not visible. They are invisible in the geometry. That's why the shape of amine is also pyramidal. Now let's read from the book. Each of 3 sp3 hybridized orbital of nitrogen overlap with orbitals of hydrogen or carbon depending on the composition of the amine. The fourth orbital of nitrogen in all amines contain unshared pair of electron, which is called as lone pair. So here this unshared pair of electron is nothing but the lone pair. Due to presence of unshared pair of electrons, the angle CNE, where E can be carbon or hydrogen, is less than 109.5 degree. For instance, it is 108 in case of trimethylamine as shown in this diagram. So here pyramidal shape of trimethylamine is shown in this diagram that we just have discussed. Now come to the classification. Amines are classified as primary, secondary and tertiary, depending on the number of hydrogen atoms replaced by alkyl or aryl group in ammonia molecule. If one of the hydrogen atom of ammonia is replaced by alkyl or aryl group, you will get RNH2 or ARNH2. This is the primary amine. If hydrogen atom of ammonia or one hydrogen of RNH2 are replaced by another alkyl group or aryl group, what would you get? You will get RNHR-. This is the secondary amine. So when we replaced two hydrogen of ammonia with alkyl or aryl group, you will get secondary amine. The second alkyl or aryl group may be same or different. Replacement of another hydrogen by alkyl or aryl group leads to the formation of tertiary amine. Amines are said to be simple when all the alkyls or aryl groups are same and mixed when they are different. For example, here. This is the ammonia. This is ammonia. So when we replaced one of the hydrogen with alkyl group, it is said to be primary amine. Now if we replace two of the hydrogen with alkyl group, these R groups may be same or it may be different. Then it is called as secondary amine. And when you replace all the hydrogens of ammonia with alkyl group, these R groups, again I am telling, they may be same and they may be different. Then it is called as tertiary amine. Now come to the nomenclature. In common system, an aliphatic amine is named by prefixing alkyl group to amine, that is alkyl amine, as one word. For example, methylamine means this is CH3 single bond NH2. So in common name system, its name will be methylamine. In secondary and tertiary amine, when two or more groups are the same, the prefix di or tri is appended before the name of alkyl group. In IUPAC system, primary amines are named as alkane amine. The name is derived by the replacement of E of alkane by the word amine. For example, if we take the same example, the common name of this molecule is methylamine, while the IUPAC name of this molecule will be methane amine. So here the name of this molecule will be methane amine. In case more than one amino group is present at different position in the parent chain, their positions are specified by giving numbers to the carbon atom bearing NH2 group, and suitable prefix such as di, tri, etc. is attached to the amine. The letter E of the suffix of hydrocarbon part is retained. For example, here there are two NH2 groups bonded to carbon. Here there are two NH2 groups and there are two carbons. It is 2 carbon long parent, so the name of this molecule will be ethane 1,2-diamine. To name secondary and tertiary amines, we use locant N to designate the substituent attached to the nitrogen atom. For example, here CH3NH CH2CH3. Here this is nitrogen. To one side it is bonded with hydrogen and other side methyl group is there, and on the other side ethyl group is there, CH2CH3. So the name of this molecule will be N-methyl ethane amine. Here we will use the longest carbon chain that contain your amine group. So this is the longest carbon chain and it contains 2 carbon long chain and it is bonded to nitrogen. So the parent name will be ethane. So it is ethane and you have to use suffix amine. So amine is the suffix and methyl is bonded to N. So here you have to write N-methyl ethane amine. Similarly for the tertiary amine, here this is CH3, CH2, nitrogen, and on this side also CH2, CH3, and here also CH2, CH3 is there. So this is tertiary amine. This is tertiary amine and this was secondary amine. Here when you write the IUPAC name of this molecule, so first of all select the longest carbon. So this is the longest carbon chain. It is 2 carbon long chain. So the parent name will be ethane amine. Ethane amine is the parent name. And here this is one substituent ethyl. This is another ethyl substituent. Both the substituents are bonded to nitrogen. So here you have to write NN-diethyl ethane amine. More examples are given in table 9.1. Now come to the aryl amines. NH2 group is directly attached to benzene ring. In aryl amines, NH2 group is directly bonded to the benzene ring. Here C6H5NH2. It is the simplest example of aryl amine. In common name system, it is known as aniline. It is also an accepted IUPAC name. While naming aryl amine according to IUPAC system, suffix E of arene is replaced by the amine. Thus in IUPAC system, C6H5NH2 is named as benzene amine. Common and IUPAC names of some alkylamine and arylamines are given in table 9.1. So let's examine the common names and IUPAC name of some of the alkylamine and arylamines given in the table. Here in the first example, CH3CH2 NH2 is given. This is primary amine. Common name for primary amine is alkylamine. And for IUPAC system, it is alkane amine. So select the longest carbon chain that includes your functional group. So here it is 2 carbon long chain. So the common name will be ethylamine and IUPAC name will be ethane amine. In the second example, Here also it is 3 carbon long chain. So the name of this molecule will be propane 1 amine. As amine is bonded to first carbon. So the name of this molecule will be propane 1 amine. In the next example, here it is again 3 carbon long chain that contains your functional. When you number the chain 1, 2, 3, amine is bonded to second carbon. So the name of this molecule will be propane 2 amine. In the next example, here 2 hydrogens of ammonia are replaced with 2 alkyl group. One is methyl, other one is ethyl. So select the longest carbon chain. Here the longest carbon chain is 2 carbon long. So the parent name will be ethane amine. And here methyl is bonded to nitrogen. So here you have to write N-methyl ethane amine. In the next example, here all 3 hydrogens of ammonia are replaced with CH3 group. So the name of this molecule will be, first of all select the longest carbon chain, as it contains just 1 carbon. So the parent name will be methane amine, and there are 2 methyl groups bonded to nitrogen. So here you have to write NN dimethyl methane amine. Now examine the next example. Here first of all select the longest carbon chain that contains your functional group. Here all the 3 hydrogens are replaced with alkyl groups. This is the longest carbon chain that contains your functional group. So this is amine functional group. Now when you start numbering the chain to the carbon which is directly bonded to nitrogen. So you have to number it from here 1, 2, 3 and this is 4. It is 4 carbon long, so parent will be butane and amine is bonded to first carbon. So it will butane 1 amine, and there are 2 substituents. Both are ethyl substituent. So here you have to write NN diethyl butane 1 amine. Now come to the next example. Here select the longest carbon chain. This is the longest carbon chain which is directly bonded to amine. When you start numbering the chain 1, 2, 3. Here there is alkene functional group, double bond is there, and amine functional group is also there. So amine will get preference over double bond. So when you write the name of this molecule, as it is 3 carbon long, the parent is propane. Amine is bonded to first carbon. So the position of amine will be 1 and double bond starts from 2. So the name of this compound will be prop 2 in 1 amine. Now examine the next example. Here NH2 single bond, CH2 whole 6 single bond NH2. So here there are 6 carbons in the chain. At first position this amine is there and here it is bonded to 6th carbon. So when you write the name of this molecule, parent will be hexane. So here you have to write hexane 1,6-diamine. Now come to the aromatic amines. In aromatic amine, here NH2 group is bonded to benzene ring. Its common name is aniline or benzene amine. And IUPAC name can be benzene amine. Now come to the next example. In the next example, here NH2 is bonded to benzene ring and substituent CH3 is also there. So you have to number it from the carbon to which nitrogen is bonded. So here 1 and this is 2. So the IUPAC name of this compound will be 2-methyl aniline. Here NH2 is bonded to benzene ring, means this is aniline, and bromine is also there. So start numbering from the carbon which is bonded to amine. So it is 1, 2, 3 and 4. So bromine is present at 4th position. So the name of this molecule will be 4-bromoaniline. Now come to the next example. Here all the hydrogens of ammonia are replaced, or you can say 2 hydrogens of aniline are replaced with methyl group. So here you can write the name of this molecule will be N-N-dimethyl benzene amine, or you can write N-N-dimethyl aniline. Now let's try to solve the in-text question. Classify the following amines as primary, secondary and tertiary. In case of primary amine, one of the hydrogen of ammonia is replaced with alkyl group. So the formula of primary amine will be RNH2. In the secondary amine, two hydrogens of ammonia are replaced with R group. So R, N, H, R dash will be the secondary amine. And for tertiary amine, all three hydrogens of ammonia are replaced with R group. So the formula of tertiary amine can be N, R, R dash, R double dash. Or you can write NR3. So here identify how many hydrogens of ammonia are replaced. Here one of the hydrogen of ammonia is replaced with this bigger group and two hydrogens are intact. So this is the primary amine. In the second example, here all the hydrogens are replaced, one with this bigger group and two with CH3. This amine is tertiary amine. In the third example, here NH2 is there and one of the hydrogen is replaced with this bigger group. So this amine is primary amine. In the fourth example, here only one hydrogen is remaining with the nitrogen and rest two are replaced with C2H5, means this is secondary amine. Now come to the next question. Write structures of different isomeric amines corresponding to the molecular formula C4H11N. And second, write the IUPAC name of all the isomers. What types of isomerism is exhibited by different pairs of amines? So let's try to draw isomers of C4H11N. Now let's draw the parent hydrocarbon that contains 4 carbons. So this is CH3, single bond CH2, single bond CH2, single bond CH2. Now attach amine to the first position. So here I can write NH2. The longest carbon chain is 4 carbon long, to which amine functional group is bonded. So when you number the chain, you have to number it from the right direction. So here this is 1, 2, 3 and 4. So the name of this isomer will be butane 1-amine. This is the first isomer that we have drawn. Now let's change the position of amine functional group. The second isomer, we can just change the position of amine functional group. So here I can write CH3, single bond CH2, single bond CH, single bond CH3. This time I can attach amine functional group to the second carbon. So here NH2. Now select the longest carbon chain. It is 4 carbon long chain. Now number the chain so that amine functional group gets the lowest possible number. So again you have to number it from the right direction. 1, 2, 3 and this is 4. The name of this molecule will be butane 2-amine. In both the structure, the position of functional group has changed. Here amine is bonded to first carbon, while here amine is bonded to second carbon. So there is only change in the position of the functional group. So that's why these two isomers are position isomer. Now let's draw another structure. So this time we can change in the skeletal structure of hydrocarbon. So let's draw CH2. Here in this molecule I can attach amine functional group at first position. So NH2. CH2, here I can write CH single bond CH3. This time I can attach one methyl constituent at this position. Select the longest carbon chain. So here this time longest carbon chain consists of 3 carbons that contains your amine functional group. Number the chain so that amine functional group gets the lowest possible number. This time we have to number it from the left direction. So 1, 2 and 3. Name this molecule. This is the methyl substituent which is bonded to second carbon. When you write the name of this molecule, you will write methyl butane 1 amine. Now let's draw another isomer. We can draw NH2 single bond C, here CH3, here CH3 and here we can draw another CH3. The longest carbon chain that contain amine functional group. This is 3 carbon long chain that contain your amine functional group. By the substituent, here substituent is methyl substituent for this chain. So when you number it, you will get 1, 2 and this is 3. And methyl both are attached to the second carbon. Name of this molecule, so here you can write 2-methyl butane 2-amine. In isomer 3 and in isomer 4, there is change in the chain. So these two are the chain isomers to each other. So you can write they are the chain isomers. So another structure. So this time we can change the type of amine. Here these 4 are the primary amines because one of the hydrogen of ammonia is replaced with the alkyl group. So this was also primary amine. This isomer is also primary amine. Third isomer is also primary amine. And the fourth one is also primary amine. Draw secondary amine. Amine, 2 hydrogens of ammonia are replaced with the alkyl groups. So here you can draw. So here we can write CH3 single bond NH. This side it is bonded to CH2, CH2 and this is CH3. Longest carbon chain. So this is 3 carbon long chain is the parent chain and there is methyl substituent which is bonded to nitrogen. So let's write the name of this molecule. So here you will write N-methyl means methyl substituent is bonded to nitrogen of amine. N-methyl parent is 3 carbon long, so the parent name will be propane. And amine is bonded to first carbon. When you number this chain 1, 2, 3. Amine is bonded to first carbon of the propane. So here you will write N-methyl propane 1 amine. Another structure by changing the length of alkyl group attached to amine. Now sixth structure we can draw CH3 single bond CH2. At the center NH is there. On the other side also CH2 and CH3. Longest carbon chain is 2 carbon long. Ethyl substituent bonded to nitrogen. Now name this molecule. So this time you will name N ethyl carbon long. So it is ethane. When you number the chain, you will number it in the left direction. So 1 and 2. Amine group is bonded to first carbon of ethane. So the name will be ethane 1 amine. In these two structures, when you see, there is change in the alkyl group. In fifth structure, propyl and methyl are bonded to nitrogen. While in the sixth structure, both side ethyl chain is bonded to nitrogen. So there is change in the chain length of alkyl group bonded to nitrogen. So that's why these two are the metamers. They are metamers. So fifth and sixth are secondary amines. Now we can draw another structure in which we can draw tertiary amine. Another structure. This is nitrogen. In tertiary amine, you have to replace all three hydrogens of ammonia. So here we can write CH3, here also CH3, and here we can write CH2, CH3. Now longest carbon chain. So this is 2 carbon long chain. When you number the chain, you have to number it from left direction. So 1, 2. Now there are two methyl substituents. These two are the methyl substituents bonded to nitrogen. So when the name of this molecule, you have to write N, N dash dimethyl ethane 1 amine. Now we can draw one more structure. Here CH3 single bond NH single bond CH single bond CH3, and here we can draw CH3. Longest carbon chain which is bonded to amine functional group. So here this is 3 carbon long chain which is bonded to amine functional group. Methyl substituent bonded to nitrogen. When you number the chain, you can number it from either direction, 1, 2, and this is 3. Now in the molecule, so here you can write N-methyl propane 2 amine. Seventh and eighth, they are the isomers. They are structure isomers. So all the structures are structural isomer to each other. Isomers to each other. In the of amine, we are going to discuss the preparation of amines.